Hey everyone, Alex here. Look at the balance sheet of almost any artificial intelligence startup operating today, and you will not see a technology company. You will see a massive high-risk financial derivative. You are looking at an entity that is essentially taking venture capital dollars and funneling them directly into the bank accounts of a few massive cloud monopolies. Welcome to the era of compute debt. Picture a quiet Tuesday morning in a sleek San Francisco office. A founder sits alone in a glass-walled conference room. The monitors are glowing with the latest user growth metrics, but the expensive artisanal coffee on the table is turning ice cold, completely ignored. This founder is not celebrating the user acquisition curve. He is staring at a flat, sterile dashboard from his cloud service provider. The server traffic data is spiking, which by all traditional software, as a service metric should be a moment of absolute triumph. But in this new era, every single time that usage line goes up, a corresponding line on the expense side goes up exponentially faster. The cost of inference, the actual physical computational energy required to generate each word, each pixel, each line of code for their users, is destroying their margins from the inside out. They are trapped in a systemic bottleneck that cannot be coded away, no matter how clever their engineering team might be. Speaking as a serial founder, when I see this kind of cash burn model, I know they will not last 3 quarters, let alone 3 years. They are building a digital mansion on rented land, and the landlord just tripled the rent. This brings us to the ultimate contrast, the massive structural pivot happening halfway across the country. While software founders are agonizing over cloud computing bills, Elon Musk and the engineers at Tesla and Zai are pouring millions of tons of concrete in Texas. They are not writing software wrappers. They are building a physical fortress. They are constructing the TeraFab. This is not just a data center. It is a fundamental reimagining of how artificial intelligence is produced, moving away from the concept of renting brains and moving toward the concept of printing them. To understand why the TeraFab is a literal death sentence for 99% of the AI startups currently dominating the headlines, we have to completely deconstruct the business physics of the artificial intelligence. We need to look past the hype of large language models and strip the machine down to its absolute bare metal components. We need to talk about hardware sovereignty versus compute debt and why the laws of thermodynamics and semiconductor manufacturing will ultimately dictate who survives the next decade of the tech industry. To grasp the magnitude of the impending collapse, we have to go back to the underlying logic of the current AI ecosystem. The past few years have been defined by an explosion of artificial intelligence companies that are, at their core, just thin software wrappers built around models trained by someone else, running on hardware owned by someone else. When the transformer architecture was introduced, it triggered a gold rush. But very quickly, a fundamental truth emerged in the engineering community. The models themselves, the neural networks, were becoming commoditized. The real bottleneck, the absolute constraint on the entire system, was the physical hardware required to train and run these models. Specifically, the graphics processing units, or GPUs. NVIDIA became the undisputed king of this domain, creating what amounts to a massive tax on the entire industry. If you want to play the AI game, you pay the NVIDIA tax. And because most startups cannot afford to buy tens of thousands of GPUs upfront, they are forced to rent them from the hyperscalers, the Amazons, the Microsofts, the Googles of the world. In engineering terms, this is a classic single point of failure embedded at the foundation of an entire industry. Let us look at the unit economics. In traditional software businesses, the marginal cost of serving an additional user approaches 0. Once you write the code, distributing it to 1 user or 1 million users costs roughly the same amount in server overhead. It is a beautiful business model with massive operating leverage. But generative AI breaks this fundamental rule. When a user asks a complex question to a large language model, the system must perform billions of matrix multiplications in real time. This requires massive memory bandwidth. It requires electricity. It generates intense heat that must be physically dissipated by industrial cooling systems. There is a hard physical cost to every single output. Therefore, the more users an AI startup acquires, the more compute they must consume. Their customer acquisition cost might be low, but their cost of goods sold scales linearly, or sometimes exponentially, with usage. This is compute debt. It is the inescapable reality that your entire business model is tethered to the pricing power of a third party who controls the physical infrastructure. Looking at their business model canvas, I see companies that are missing the most critical component of long-term survival, which is control over their primary means of production. They are raising hundreds of millions of dollars in venture capital, not to innovate on core technology, but simply to subsidize their cloud computing bills in a desperate attempt to gain market share before the money runs out. It is a high-speed game of musical chairs played with billions of dollars, and the music is about to stop. The illusion of the software moat is evaporating. Software is infinitely replicable. Hardware requires atoms. It requires supply chains, raw materials, manufacturing yields, and massive capital expenditure. The startups operating in the compute debt model are trying to solve a hardware physics problem with software marketing. It simply does not work. Let us dive deeper into the technical reality of this bottleneck. A modern GPU cluster is a marvel of engineering, but it is also a highly constrained system. When you are training a massive neural network, the limiting factor is rarely the computational speed of the chips themselves. The limiting factor is memory bandwidth. It is the speed at which you can move data from the memory chips to the processing cores and back again. This is known in computer science as the memory wall. To overcome the memory wall, companies like NVIDIA have developed incredibly complex and expensive technologies like high-bandwidth memory and proprietary interconnects to link thousands of chips together so they can act as. The cost of manufacturing these specialized systems is astronomical. The packaging of the silicon, the precision required to align the microscopic connections, the testing, the yields, all of it contributes to a massive physical premium. When a startup rents compute from a cloud provider, they are paying the amortization of that premium, plus the cloud provider's profit margin, plus the energy costs, plus the real estate costs of the data center. If we treat this business model like a physics problem, the inefficiency is staggering. You have a massive chain of middlemen, each extracting a layer of profit between the raw electricity and the final artificial intelligence output. The startup at the end of this chain is absorbing all of the friction and all of the cost. They are operating with structurally inverted margins. They are hoping that eventually the cost of compute will drop faster than their venture capital runway depletes. But this is a deeply flawed assumption. As models become more capable, they require exponentially more parameters. A model with 1 trillion parameters requires vastly more compute to train and run than a model with 100 billion parameters. The demand for compute is outpacing the advancements in semiconductor manufacturing. Moore's law is slowing down, and the cost per transistor is no longer dropping at the historical rate. The physics are working against the software companies. Now, let us transition to the climax of this systemic shift. We have established the fragility of the compute debt model. Now we must look at the brutal, unyielding alternative being built by Tesla and Zaki. The TeraFab is not merely a factory. It is a declaration of war against the entire cloud computing paradigm. To understand the gravity of the TeraFab, we must visualize the sheer scale of the operation. Imagine a facility so massive that its internal geometry resembles a small city. We are talking about gigawatts of power consumption. We are talking about electrical substations built specifically to feed this single entity. The cooling systems require pipes large enough to walk through, pumping millions of gallons of coolant to draw the thermal exhaust away from the silicon brains. The strategy here is hardcore vertical integration. Elon Musk understands that in the end state of artificial intelligence, the company that controls the physical layer controls the entire stack. By building custom silicon, the A and eventually AI low chips, Tesla is designing hardware explicitly optimized for their specific neural network architectures. They are stripping out all the generalized overhead that makes standard GPUs so expensive and power-hungry. They do not need their chips to render video game graphics or run legacy database queries. They need them to do one thing with absolute ruthless efficiency, which is matrix multiplication for artificial intelligence. By manufacturing these chips and deploying them in their own massively scaled facilities, they are bypassing the NVIDIA tax and the cloud provider tax entirely. Let us picture the chain reaction of the collapse that this physical reality will trigger in the broader market. It will happen quietly at first, and then all at once. Return to our hypothetical startup founder in San Francisco. It is the end of the quarter. They need to train their next generation model to stay competitive with the open source community and the major tech conglomerates. They go to their cloud provider to reserve a cluster of 100,000 latest generation GPUs. The cloud provider informs them that there is a 12-month waitlist and the price per hour has increased by 40% due to energy constraints and overwhelming demand. The founder runs the math. The cost to train the model will consume 80% of their remaining cash on hand. If the training run fails, which happens frequently due to hardware faults or algorithmic instability, the company is instantly bankrupt. If the training run succeeds, they will have a state-of-the-art model for approximately 3 months before a larger competitor releases something better. In my experience building hardware and software systems, this is the exact moment you realize you are playing a rigged game. The startup attempts to raise a Series C round to cover the compute costs. They walk into the venture capital offices on Sand Hill Road. They present their user growth, their engagement metrics, their clever software application. But the venture capitalists are looking at the gross margins. They see the massive bleeding wound of compute debt. They see that for every dollar of revenue, the company is spending $1.20 on server costs. The venture capitalists ask the fatal question: how do you defend your business when a vertically integrated giant can offer the exact same service for a fraction of the cost simply because they own the power plant, the cooling towers, and the silicon? The founder has no answer because there is no answer in software. The check is not written. The runway evaporates. That Tuesday, he sits in his office watching the server traffic data flatline to zero. The servers being physically shut off by the cloud provider for non-payment, the coffee in his hand turning ice cold as the realization this scenario will play out hundreds of times over the next few years. We will witness the mass extinction of the compute debt startups. It will be a brutal, systemic cleansing of companies that confuse the software feature with a sustainable business model. The capital operations underlying this collapse are entirely predictable. The massive valuations awarded during the initial hype cycle were based on the assumption that artificial intelligence was a software market with software margins. But as the physical constraints bind tighter, those valuations will compress violently. Companies that were worth $5 billion on paper will be sold for parts, their only valuable assets being the small handful of talented engineers who actually understand the underlying math. Meanwhile, the TeraFab comes online. Let us break down the frame-by-frame operation of this vertically integrated behemoth. Tesla is not just building a data center. They are building a self-reinforcing manufacturing loop. The TeraFab produces the compute. The compute trains the models for autonomous driving and the Optimus humanoid robots. The robots and the cars gather massive amounts of real-world video data. That data is fed back into the TeraFab to train the next generation of models. It is a closed-loop system of physical and digital capital accumulation. Every time a Tesla drives down the street, it is gathering training data for free. Compare that customer acquisition cost to a software startup that has to pay millions of dollars to license synthetic data or scrape the internet. When you look at the energy dynamics of the TeraFab, the engineering advantage becomes even more stark. Running gigawatts of compute requires massive energy contracts. Tesla, with its deep roots in battery storage and solar technology, is positioned to build energy infrastructure directly alongside the compute infrastructure. They can smooth out the power draw, store energy during off-peak hours, and utilize massive battery packs to provide uninterruptible power to the training clusters. A software startup renting server space in Virginia has absolutely zero control over the energy mix or the cost of electricity. They are entirely at the mercy of the grid. If the price of natural gas spikes, their cloud computing bill spikes. Tesla is insulating itself from these macroeconomic shocks through sheer physical ownership. This brings us to the postmortem and the rebuild. How do we summarize this massive shift across the dimensions of business laws, human greed, and technological evolution? First, we must rewrite the laws of business for the artificial intelligence era. The era of the lean startup, where you could build a billion-dollar company with a laptop and an Amazon Web Services account, is officially over when it comes to foundational artificial intelligence. AI is not a software industry. It is a heavy industry. It is more akin to oil refining, steel manufacturing, or aerospace engineering than it is to building a social media app. It requires massive capital expenditure, intense regulatory navigation regarding power and water usage, and a deep understanding of physics and materials science. The human greed element is also a critical factor in this teardown. The compute debt bubble was inflated by a collective delusion among venture capitalists and founders who desperately wanted the old rules to apply to the new technology. They wanted the massive returns of software without the messy, difficult, capital-intensive reality of hardware. They convinced themselves that they could abstract away the physical layer. But physics is unforgiving. You cannot abstract away a thermal limit. You cannot write a Python script to bypass a memory bandwidth bottleneck. The greed blinded the market to the fundamental unit economics of intelligence. The massive influx of capital into wrapper companies was a misallocation of resources on a historic scale, driven by the fear of missing out rather than rigorous engineering analysis. Looking at this from a pure systems architecture standpoint, the evolution is clear. We are moving from a distributed, rented architecture to a centralized, owned architecture. The companies that will dominate the next century are the ones achieving hardware sovereignty today. They are the new Standard Oil. Just as John D. Rockefeller realized that controlling the refineries and the pipelines was the key to dominating the energy market, Elon Musk realizes that controlling the silicon, the power, and the cooling intelligence is no longer an abstract concept. It is a manufactured commodity. It is printed on silicon wafers, cooled by liquid, and powered by the electrical grid. For the founders and builders out there, the lesson is absolute. If you are building in artificial intelligence, you must deeply understand your relationship to the physical layer. If your entire business model relies on the assumption that compute will get cheaper and that the cloud providers will pass those savings on to you, you are building a house of cards. You must either find a niche where the compute requirements are negligible, or you must build a product so incredibly valuable that you can pass the massive cost of compute directly onto the consumer without destroying demand. The middle ground is a death trap. You cannot compete on raw intelligence against an entity that owns the factory that prints the brains. The TeraFab is a monument to this new reality. It is a physical manifestation of the exact point where software engineering collides with heavy manufacturing. The startups that ignore this collision will be crushed by it. They will slowly bleed out, their capital drained by the inescapable tax of compute debt until their servers are quietly spun down and their domains are left to expire. The future of technology belongs to the pragmatists, the builders who are willing to pour the concrete, string the high voltage lines, and optimize the thermal dynamics. It belongs to those who understand that in the ultimate analysis, the digital world is completely subservient to the physical world. The software dream is over. The hardware reality has begun.